We're now less than 2 days from the official start of winter in the Northern Hemisphere, and as we like to do at the beginning of every astronomical season, we sit down and chat with our resident astronomer, Dr. Chris Palma, from the Penn State Department of Astronomy and Astrophysics. Always good to see you, Chris. We often start with a little bit of an update on spaceflight, manned spaceflight, and I saw that NASA had recently announced that this new manned mission to the moon called Artemis has been pushed back even further. You know, just seems to me as a scientist but layperson when it comes to astronomy, we've done this before. What is taking so long?
I do think the big difference, like if you think back to the early days of human spaceflight, they were test pilots, right? And they were, it is incredibly dangerous, and I think we forget about that. And I mean, I always feel badly. I mean, depending how old different folks are, you probably remember the Columbia disaster, the Challenger disaster, right? And so NASA today, compared to NASA way back when, is much, much more worried about safety. Not that they didn't take it seriously then, but it is paramount. And they want to make absolutely sure that before astronauts go past the moon, that these vehicles are 100% safe for them to do so.
And whether you know, like it or not, sometimes accidents like that make you much more safety conscious.
Yeah.
So we've also talked before about these things called NEOs, or near Earth asteroids, near Earth objects. These small space objects that come close enough to Earth that you kind of got to track them. And it's my understanding that this Webb Space Telescope is now able to see even tinier chunks of rock out there. I got to believe that's a good thing.
Yeah, for sure. So, and it's kind of funny, like in an astronomical context, what does tiny mean? So the rocks that they're able to find are probably bigger than a house, right? But if you think of the largest asteroids in the asteroid belt, they're bigger than State College, right? So the asteroids we've known for a long time are absolutely huge, and we're safe from those. They're not going to move. But the small ones are the ones that are actually able to get shifted in their orbits and could potentially become dangerous. So the better we're able to track these small ones, the better we're actually able to predict, are we safe and will we be safe for a long time?
And there's a whole sort of sub-branch of your field, folks just tracking these objects.
Absolutely.
And some of them come within, you know, the distance to the moon, to the Earth, and they pass by harmlessly.
One of our alumni is actually one of the top people in the country doing this work.
Really? Okay. I love planetary news, and there's always been questions about whether either of our neighbors, Venus or Mars, was ever habitable. And I guess now there's mounting evidence that, at least in the case of Venus, the answer is no.
You always have to say, well, maybe, right? So this article that you may have read recently talked specifically about water. Like when we're looking for life elsewhere, we really focus on, could this planet have had water, or does it currently have water? And so more and more it seems like the evidence for Venus is that the likelihood that there were substantial amounts of water on the surface may now be pretty unlikely.
Okay.
But does that mean there was no life? Maybe not. It just means the types of life that thrive in water we're probably not able.
And you know, speaking of Venus, I saw that your department recently hosted a prominent astrophysicist from MIT, Dr. Sarah Sager, I believe was her name, and she's done some Venus-related research. What did she say when she was on campus?
Well, it's so funny because she said the opposite, essentially, right? And again, I think this is fun to talk about here in particular. Let's say the surface wasn't habitable because there wasn't a lot of water, and we think of this, you know, atmosphere that's full of sulfuric acid as being very, very awful for us, but could there be living things that thrive in sulfuric acid? And so that's actually one of the things she studied. She's gone back and been doing some interesting chemistry experiments as an astronomer to try and decide whether or not organic material could live in that atmosphere.
Okay, so it's often based on life as we know it, as opposed to life that could be different. Yeah. I saw some neat research from your department recently. You astronomers, I say this all the time, are so good at finding exotic objects. And when I saw the terms super puff planets and cotton candy in the same press release from your department, of course I was intrigued. What's this new discovery?
Well, I think it really points to how we find planets, right? We can't see a distant planet around another star. What we can do is indirectly detect how massive they are and indirectly detect how big they are. And so we found massive planets that were much larger than normal. And these are gas giants that are already very low density. And so a superpuff is a low density planet, so low density that it really took us by surprise.
And cotton candy entered into the conversation as a way to describe it. One of your faculty members at the Barron campus recently proposed a new theory about how Earth got its moon. Tell us a little bit about that.
Yeah. So the dominant theory for a long time is that an object impacted the early Earth, threw enough rock up in orbit around us, and that rock coalesced to form the moon. But we also know in a lot of different situations in space, let's say you have a pair of objects orbiting each other, and they come across a solo object, you can get an exchange reaction, where this pair breaks up, and it donates one of the two objects to that one. And it turns out that's possible for the moon. We could have captured the moon from an early protoplanet.
Interesting. So just a little bit of time left. We always like to close. Do you have any sky watching tips over the holidays?
Well, I've heard from folks who ask me to talk more about stars and constellations, and lots of those folks often say the only stars they know are Orion. So if you want to break out from that, if you can find Betelgeuse and Rigel in Orion, there's a nice group of stars that almost forms a circle. It's called the winter hexagon. So you can go from Rigel to Sirius to Procyon to Castor and Pollux to Capella to Aldebaran. And if you just look to the east, you will see that winter hexagon of stars.
And Sirius would be the brightest star
Yes.
in all of those. Yep. Dr. Chris Palma, Penn State Department of Astronomy and Astrophysics, thanks for stopping by. And we will be back in a moment with more.